Hello, how are you? Are you fine? Can you hear me? Are you fine? Can you hear me? Can you hear me now? Can you hear me? Okay, so we're going to start. Okay, we're going to start now, please. So, pay attention. We're going to work about light energy. You know that light energy is a form of energy, a very important form of energy. You know many other forms of energy. You know that there are many of them. So among them, we can find mechanical energy that is composed of kinetic energy and potential energy. You know that we have studied just some days ago about thermal energy or heat energy. It's the same thing. And now this is a very interesting theme about light. So, and the first thing we are going to study is about what light energy is. And to do that, I'd like you to watch a very interesting video clip and be very attentive. And remember, you got to keep clean the chat. Pay attention now. Remember, I have here some documentaries. If anyone of you is interested in them, the only thing you have to do is ask me for them. Okay? Good. So pay attention now.
Light. Have you ever been at home when there was a big storm and your lights went out? Or have you been in a room and suddenly someone turned off the light? What happened? How did you feel? You may have felt confused because you couldn't see anything around you. Light is something we need and use all the time. When it's not there, we realize how much we need it. Light is a form of energy. We cannot feel light. We can only see it.
We cannot feel light. The only thing we can do with light is see it. Remember that.
Light comes from both natural and man-made sources.
This is about the different sources of energy from that we can get light. So there are man-made, artificial, and natural sources of energy, of light in this case.
Our natural source of light is the sun. The sun is a huge ball of gas. It gives off a lot of energy in the forms of light and heat. The sun is a star that is very far away from us. It's so far away that it takes about 8 minutes for its light to reach us here on Earth.
This is important. So, more than 8 minutes takes light to arrive to the Earth from the sun. More than 8 minutes.
Sunlight helps us to see everything around us during the day. It also provides the energy for everything on Earth.
Sun is all important for life on Earth. All important for life on Earth. Without sun, no life on Earth. Okay, why is it? Because plants need sunlight to make their own food, and we need plants. We and all animals, all living things on Earth. So we need sun. So sun is the source of energy for all of us, all living things.
What is another natural source of light? The stars give off light too.
But stars are very far away from us. Okay? It's farther away than the sun. Okay, and you remember that the sun is another star. Okay.
They are like the sun, only much farther away. What about the moon? The moon gives no light of its own. It reflects the light of the sun.
So the moon has no light inside. The moon has no light inside. So you have here the moon, and the only thing that the moon does is to act as a mirror. So it reflects the light that comes from the sun, and it arrives here in the earth at night,
giving us some light at night when we don't see the sun's rays. Fire is also a source of light. Long ago, people used fire to see in the dark. They carried torches or candles. Let us now see some man-made sources of light. These days, most people use electric lights. An electric light bulb is made of a wire that glows when a current flows through it.
So in the next theme, we're going to study about electricity. Okay, and this is a bulb light. Okay, and inside this vacuum. That means there's nothing there, no oxygen, because just a little bit of oxygen could make this filament, this wire, to burn.
It gets very hot, but because it's in a bulb with very little oxygen, it can't get hot enough to catch fire. Neon lights are a different kind of light.
Neon lights. So these are the lights you can see at night in many places, many buildings. Neon lights, and the thing is that inside you have a gas, and this gas blows when it's attached to the electricity. Neon gas. In Spanish, neon. It's a kind of gas.
They are used a lot for signs. They're made from a gas that glows when electricity passes through it. Laser lights are thin, powerful beams of light.
This is laser, okay? All of you and I at home, we have laser lights. When you are taking your el mando a distancia, I don't know exactly the name in English, you are emitting laser lights. You can't see them, but they are there.
They're made of only one color. Lasers can be focused on a very small spot. Also, the light from a laser can go a long distance without spreading out like other lights do.
Okay, that's all. And now we're going back to our notes, and this is the text part, and you have there the basics about light. So, what is light? Light is a form of energy, okay? And this is a form of energy which our sense of sight, okay, can detect. And it is made of electromagnetic radiation and travels in straight lines, línea recta, straight lines. Good. See, this is light. And light is simultaneously, at the same time, a wave and a particle. Here, you have the wave. Okay, this is a wave, but this wave is traveling in a straight line, okay, from left to right, okay, but inside you have a wave. So light is a component of two things, a wave and a straight line. Okay, and this is a wave and a particle. Can you see here the particle? These particles that are moving all along this path are called photons. Fotones in Spanish. Photons. So this is light. Very good. And we have some characteristics of lights. One of them is about the speed of light. And the speed of light is the most interesting thing is that speed of light is about 300,000 kilometers per second. Okay, nothing travels faster than light. Okay, and the speed of light changes when traveling through different objects. It's not the same when light is traveling through water, through air, and through the vacuum, el vacío. Okay, the space. This is different. Is different. This is the first thing. So the speed of light. Remember this figure. This is very important. 300,000 kilometers per second. Nothing is faster than light. Nothing in the universe. Then the colors of light. This is important. I bet you know that. So light is composed of many waves. You remember these are only 3 of them, but there are many of them. Some of them are colors we can see, but in fact there are millions. We can see about 7 colors. The 7 colors of the rainbow. Okay, there are millions of there. And all of them compose light. And finally, the third thing you have to remember is that light can't be stored. No puedes almacenar la luz. You can't store light. You can't store light. Okay? Why? Because light is always moving. You can store light. Very good. And now I have for you another interesting video clip. Pay attention because this is another very interesting video clip about light.
Oh, it's dark here, and I can't see you. Oh, wait. Hey there. Wonder what we do without lights, right? So come on, let's talk about light today. Zoom in. Light is a form of energy made of photons.
Okay, photons, remember, photons are these little particles that travels in straight lines and following a wave. Okay, the two things. So, straight lines and they are following all along a wave. Photons.
A photon is the smallest unit of visible light. Now you ask me, how does light travel? Well, light is unique as it behaves both like a particle and a wave.
Okay, a particle, photon. A photon. This is the particle. The name of the particle is photon. Okay, it's a very tiny particle. Okay, and a wave. You remember these spots are the particles, the photons, and this is the wave.
That behaves differently with different kinds of matter. If light hits an object and passes through it, that object is known as a transparent object.
The transparent objects are objects that let pass through light. Okay? So your window, okay? The crystal of your window, the crystal of your glasses, okay? These are transparent objects. Why? Because they let pass light. Transparent.
Let's do one thing. Take a glass of water and switch on a torch. See the light passing through?
Okay, so water is transparent. And the crystal, the glass of water, is transparent too. So that's why light can travel through it.
Well, this proves that water is transparent. There are certain objects through which light cannot pass.
These are rocks. Okay, and these are rocks keeps light from passing through it. So this is not transparent. Okay, this is opaque.
And it changes its path after hitting the object. These objects are called opaque objects.
So all in all, we have up to now we have transparent objects, opaque objects, and we have another kind of objects there. Pay attention.
Such as wood, the mobile you're using right now, and you as well. Yeah, humans are opaque as well. Some objects allow light to pass through them partially, and they are known as translucent objects.
So, translucent objects are objects that let pass just a little fraction of light. Okay, you can see through them that behind the object there is light, but you can see the shape exactly. They are translucent objects. So many bottles, for example, okay, the crystal of many flasks or many bottles are translucent objects.
Such as plastic, butter paper, and frosted glass.
Okay, plastic, butter paper, and frosted glass. These are translucent objects. They let pass light through them, but only a tiny fraction. You can't see clearly the shape of the object that is behind. They are translucent objects.
And do you know what travels the fastest? No, not a space rocket. Well, it's light. In vacuum where there's no obstacle, light travels at a speed of more than 0.1 million miles per second.
Okay, so you had to know it in kilometers per second. 300,000 kilometers per second. Okay, and this is the speed of light in the vacuum, in the space. And why is it? Because the space is composed of nothing. Okay, this is vacuum, no matter there. Okay, no matter, no obstacles. So light travels faster in the universe. Why? Because this is vacuum, es el vacío. Nothing is there.
Okay, so the distance between the sun and Earth is 93 million miles. But it takes only 8 minutes for light to reach the Earth.
Yes, Miguel or Manuela. Yes, big is a translucent object. Okay, you can see behind this pen, but only a tiny fraction is translucent, not exactly transparent.
That's a whooping speed, isn't it? When light travels through different mediums, it slows down and sometimes bends.
Attention, bends means that's a change direction. Okay, se desvía. Okay, it all depends on the liquid or the object. Attention, this is very important.
And this bending of light is known as refraction.
Refraction is the bending of light when light travels through an object. Now pay attention.
Take a beaker filled with water and place a pencil in it. Now look carefully.
Okay, so you are used to seeing that. Okay, it's not because of the pencil, it's because of the light. Light we are seeing is deflected. That's why that looks like this is broken or bent.
Do you see a bend in the pencil? No, the pencil didn't bend. The light rays just got refracted. That's why you see the pencil bent. Trivia time! Did you know that humans are bioluminescent, which means that they emit light?
I didn't know that. Okay, so we are bioluminescent, so we can emit light. I think a very little fraction, a very little part. We are bioluminescent. And there are some insects that are bioluminescent. You know that.
But their glow is 1,000 times weaker than what the naked eye can register. Light takes approximately 1.2 seconds to reach the moon from the Earth. So friends, did I not light up your tickling brain cells today? Tune in next time for more fun facts. This is me zooming out.
Good, good. Interesting. Very good. Now go back to our. Sorry. I want to. Okay. To our text part. So we have here types of light energy. And we have visible light, infrared light, and X-rays and ultraviolet light. Visible light is light that can be seen through the naked eye. Con el ojo desnudo, con el ojo, okay? A simple vista, through the naked eye. Examples: light emitted by sun, lanterns, flashlights, light bulbs. Okay, this is visible light. But there is a kind of light that we can't see. Okay, but one thing is that we can't see a kind of light, and quite a very different another thing is that this is not light at all. This is light, but we can't see. So, infrared light is non-visible light. It also emits heat, okay? Infrared, rayos infrarrojos. Examples: remote control. This is the name for remote control, and to switch on the TV set. And there is another kind of rays that compose light that are called X-rays and ultraviolet light. So short light waves used by doctors to take photographs inside our body. Okay, and now we go to our exercise part. All of you, please. All of you. And we have here a text. You had to do this text the other day. And many of you sent it to me, and we're going to correct it. So, light energy. Remember, it's the text reads this way: light is one form of energy that travels in electromagnetic waves. Okay, don't worry about this word. We're going to next theme about electricity. We're going to talk a little bit about electromagnetic waves. But an electromagnetic wave is this wave that is composed of photons and travels in straight lines. Remember that. And there are many different types of electromagnetic waves, and this EM stands for electromagnetic waves. Most of them cannot be seen by humans. Our eyes see only a small portion of EM waves called visible light. We know that because we have studied that. Visible light is made up of different colors. The colors are red, orange, yellow, green, blue, indigo, and violet. Indigo is a kind of dark blue. Okay, dark blue. And before red, we have more rays, and they are called infrared. And after violet, there are more rays, and they are called ultraviolet. So when you hear infrared lights, you have to remember the composition of the colors of lights. And behind red we have infrared, and after violet we have ultraviolet rays. The colors are due to the different wavelengths of light. Okay, light travels out in all directions from its source. What are some sources of light? The sun is our main source of light on Earth, you know. And some other sources are other stars and fire. And finally, light is made of little particles called photons. A photon is the smallest possible particle of electromagnetic radiation, and this particle travels in waves. Remember, two things: they travel in waves, but following a straight line. Remember that. And the questions are these. So, for the first one, I need your contribution. So, number one, light is visible energy to the human eye. What do you think? Is it true or false? Light is visible energy to the human eye. What do you think? Waiting for you. What do you think? It's true or false? Waiting. Light is visible energy to the human eyes. You think it's false? No, that's true. Okay, that's true. Although there are some waves into light that we can't see. Okay, but all in all, light is visible energy. Okay, this is the only visible energy. Thermal energy is not visible. Nuclear energy is not visible. But light is the visible energy that we can see. Very good. So, number 2, pay attention. Light energy is both magnetic and electrical. What do you think? True or false? Light energy is both magnetic and electrical. What do you think? True or false? Waiting for you. True or false? True, false, Julia? Difficult. Can't be. You have to choose. Both magnetic and electrical. Remember, here we have electromagnetic. So this is the key. So this is at the same time magnetic and electrical. This is true. This is true. This is true. Go to number 3. All the light energy waves are visible. What do you think? All the light energy waves are visible. What do you think? True or false? Waiting. Number 3. All of them are visible. You think? What do you think? Can we see all light energy waves? Good, Rodri. Good, very good. Very good, Inez. Very good, very good. So this is false. We can only see a tiny fraction, a tiny portion of the energy waves. Okay, but there are some. They say that there are some animals that can see more waves than us. Okay, they say. Very good. So, okay, it looks that you can't see me, but this is not important. You have to follow this class here. So number 4, light energy is energy that travels in straight lines in just one direction. What do you think? What do you think? Is that true? Is that true or false? Just one direction. Remember, we have here light. Here, light travels out in all directions from its source. So this is not true. Okay. Okay. So remember, light travels in straight lines, but this straight line can be in all directions, in all of them. And finally, number 5, photons are bundles of light energy. Bundle is a kind of pack, a little pack of light energy. Photons are bundles of light energy. What do you think? Is it true or false? Is it true or false? Photons. Remember, photons are these particles, these little particles that light is composed of. What do you think? Photons. Ines says true. Not very sure. Celia, this is false. Julia is true. Celia, pay attention. Photons are little particles. A bundle is a little particle, a parcel. Okay, that's true. Very good. And I'd like you to tell me if you knew about these 6 things. So, The speed of light is about 300,000 kilometers per second. Do you know that? Do you know that? Yes or not? You know that the speed of light was about, no, not 300 kilometers per second. That is a lot. 300,000 kilometers per second. What do you think? You know that? Number one? Did you? Ines says no. You need to remember this by heart. 300,000 kilometers per second, not per hour, not per minute, per second. A lot. This is a lot. Good. Go to the number 2. During photosynthesis, plants use light energy to create chemical energy to make their own foods. So, do you know that? During photosynthesis, plants use light energy to create chemical energy. Do you know that? Did you? Do you know that during photosynthesis, plants use light energy to create chemical energy? Yes, I think all of you knew about that. Very good. We have studied that in our class in 5th grade. Now, number 3, there are millions of colors in a rainbow. You know that there were more than 7 colors, but millions of colors in a rainbow. Sorry. So the thing is that we can only see 7 of them. There are millions of them. So did you know that? Millions. Isn't it surprising? Millions. From the unit, Ines. Yes? Okay, very good. So, although humans cannot see ultraviolet light, some insects have the ability to see it. Yes. I don't know in English the name of luciérnaga. Okay? In Spanish we call it luciérnaga. In English I don't know exactly the name, but this is one of the insects that have the ability to see it and to produce this kind of energy. Let's move to number 5. So, space is dark because light is only visible when it has an object of which to bounce off. You know that? Yes. That's why space is dark, because there is nothing there. When there is a planet or a satellite or whatever, you can see it, because light hits the satellite of this planet and we can see light. Very good. And finally, number 6, light energy is always moving and can therefore not to be stored. You know that? Okay? You can't trap light in a box. This is impossible. Very good. And remember, for today, you have to do the exercise number 15 and 16. Okay, we're going to correct it in other moments. And now I'd like you to watch another video clip. And this is about the lights of
Hay un orangután en mi cuarto y no sé qué
the rainbow.
hacer.
Pay attention.
Ha cogido mis juguetes.
Light. It's all around us. But what is it? Where does it come from? And what does light have to do with color? Light is a kind of energy that travels in waves.
Can you see? Waves? These are waves of light, and they are traveling in straight lines in all directions. This direction, this other direction.
It is made when matter is heated up or gains energy. Excess energy is released, in part, as light. This energy is called electromagnetic radiation. When we talk about light, we usually mean visible light, which is the light that we can see with our eyes. But there are more types of electromagnetic radiation that are invisible to us, including radio waves, microwaves, X-rays, and gamma rays. Scientists can detect and measure invisible radiation with special tools. Together with visible light, all these types of radiation are called...
Can you see? Electromagnetic spectrum. And this is the spectrum, this little fraction is the spectrum of light that we can see. Okay? So before red, we have infrared lights. And after violet, we have ultraviolet lights. Take care with ultraviolet lights. That's why we take cream, sun cream to protect, to keep us protecting from the sun. So ultraviolet light. These are other waves that compose light. So ultraviolet, after violet, and before red we have infrared, and all of them are electromagnetic waves.
Called the electromagnetic spectrum. All electromagnetic radiation travels in waves, but different types have different wavelengths. The wavelength of electromagnetic radiation, or light, is connected to how much energy it has. Light with a longer wavelength, like radio waves, has less energy, while light with a shorter wavelength...
Can you see here? So this is visible light, and we have ultraviolet, X-rays, or a kind of ultraviolet rays, and we need to be protected from these X-rays, gamma rays. These are rays we can't see, but they are there. Okay, they are there. And behind red we have infrared, microwaves, and radio waves. All of them are forms of energy, and all of them are somehow in light.
Like gamma rays, has more energy. Visible light makes up only a tiny part of the electromagnetic spectrum, but it includes every color we can see. The most important source of light here on Earth is the sun. We call ordinary sunlight white light, but it actually includes all the colors of visible light. These colors can be revealed when white light goes through a prism.
It's a prism. This is a prism, and this ray of light. And this ray of light is going to go through the prism. It's going to be deflected, okay? Going to bend here, and finally, you're going to see the 7 colors of light that are visible to the human eye.
When light passes through a prism or something like it, it slows down a little bit.
Okay, these are the 7 colors. These are here inside, and this is a prism. And this prism has the property to decompose light. It's a prism. It could be a kind of crystal, but could be a water drop. That's why we can see the rainbow in the sky.
And bends. Some parts of the light slow more than others, and the light spreads out into the colors of the spectrum. If you want to see all of the colors in the visible light spectrum, look no further than a rainbow. Rainbows are made when water droplets in the air bend sunlight much like a prism. Usually when we talk about a rainbow, we say it is made of 7 colors: red, orange, yellow, green, blue, indigo, and violet.
Remember indigo? This color here, indigo, is dark blue. In Spanish, we have a word that is añil, con ñ, añil. Okay, this is dark blue, indigo.
Each color has a different wavelength. Red has the longest wavelength in the spectrum of visible light, and violet has the shortest wavelength. All the other colors have wavelengths in between the two. The colors of a rainbow are always in the same order, because the colors are arranged according to their wavelengths. Red is always on the outside, because red has the longest wavelength. and violet is always on the inside, because violet has the shortest wavelength. Electromagnetic radiation with a wavelength outside the visible light spectrum is invisible to our eyes. Light with a longer wavelength than the reddest red our eyes
Okay, this is an image. This is an image. This is an image that we can't see with our naked eye. We need another tool. We need to have a tool to see that. Okay, so these people here can't see these two animals. We need something different, a tool to be able to see these animals at night.
can see is called infrared light. Light with a shorter wavelength than the most violet we can see is called ultraviolet. When we look at an object, we are actually seeing the light that is bouncing off of it. A green leaf looks green because the leaf absorbs all of the colors in the spectrum.
Attention, this is green because all the other colors are absorbed by this leaf, okay? And green is ejected. That's why we see this leaf green, because the other colors are inside the material.
Except for green, which it reflects. When the green light enters our eyes, our brain tells us it looks green. Things that look white are reflecting almost all of the visible light shining on them, and things that look black are absorbing almost all of the...
Attention, you see things that are black because this material, this fabric, maybe absorbs all the rays. And if you see something that is white, this is because all these waves are ejected, are deflected. We can see all of them. So white is the sum of all colors, and black is when there is no color at all.
The visible light shining on them. Light, both visible and invisible, is all around us. It travels from its source as a wave, bringing energy with it. Without light, there would be no colors. Take a look at the world around you and remember, everything you can see is just different wavelengths of reflected light. Goodbye till next time.
So very good. And now, please, this is the end of our class. So sorry for your hours. And now we're going to finish this transmission. I don't know exactly. And now this is the end for today. See you soon.